19, the inverse relationship between logarithmic and exponential functions. So this opening exercise says for us to consider the mapping diagram below. They've got two functions, one for f and one for g. It says fill in the blanks of the mapping diagrams of g, which would be over here, to construct a function that undergoes each output value of f by returning the original input value of f. The first one is done for you. So in function f, it says 1 maps to 3, 2 maps to 15, 3 maps to 8, 4 maps to -2, and 5 maps to 9. Again, this side here is the domain, and this side here is the range. So in G, what they did was one of them for us, where it says -2 maps to 4. And so what they want us to observe is the relationship between here and here. So with that being the case, we see that they are just backwards of each other. So if we were to follow this pattern and make this observation, 3 would have to map to, so we would find that 3 on the range side would have to map to a 1. So we put a 1 right here. The 8 maps to something, so in reverse, 8 maps to 3. 9 is going to map to 5. And 15 is going to map to 2. So they reverse each other. They are inverses of each other. In other words, we basically just switched the x's and the y's. And so you're going to see that theme today. So I'm going to just write that down. Our theme today in this lesson will be to switch the x and the y values between functions. So with that being the case, right, they give us in part B, write the set of input-output pairs for f and g by filling in the blanks. So they gave them to us in one order. They want us to put them in the other order. So this was the first one in our mapping diagram right here. The second one would be 3, 1, and 8, 3. So we're just going to fill those out. So this would be 3, 1, and then we would have 8, 3, and then we would have 9, 5, and then 15, 2. In C, how can the coordinates in the set of G be obtained from F? And this is the theme that I had told you about. We are pretty much switching the X and Y values. And in part D, it says, Peter studied the mapping diagram of the functions f and g above and exclaimed, I can get this mapping diagram by simply taking G, simply by taking the mapping diagram for f and reversing all the arrows. Is it correct? And we would say, not quite. Not quite. Let's see, spelled that correctly. Not quite. He needs to also switch the words domain and range. He can't just switch the arrows on this diagram. So again, just as what Peter was suggesting. Peter suggested we just take and, let's see, take our arrows and turn them the other direction. But if we were to do that, right, we'll draw those over here. 3 does map to 1, 15 does map to 2 in this one, but we need to change our terminology as well, and not just the other information. So in F, for each function F, right, we'll put a little space there. In exercises 1 through 5, they want us to find a formula for the corresponding inverse function G. Graph both functions on a calculator. For us, that calculator will be Desmos, and then check your work. So remember our theme, right? we told you we're going to take and we're going to switch x and y. So the other thing that I'll mention is every time you see f of x, that's the same thing as saying y. So if we did number 1, right, we'll just mark number 1 to refresh what we're talking about. We're going to write y equals 1 minus 4x. So I want to find the inverse to this. So what I'm going to do is I'm going to follow my theme. I'm going to switch x and y. So my y is going to become an x, and my x is going to become a y. And at that point, we're just going to solve for y. So I'm going to minus 1 to the other side, so I get x minus 1 equals negative 4y. Then I will divide by negative 4 to the other side. And so I'm going to end up with x minus 1 divided by negative 4 is equal to y. And if you wanted to simplify this, you may. It's up to you, but this is fine the way that it is. And so that would be our inverse function. So if we went to Desmos and type that in, we could do that. So I'll pull that up and see. And so let's see, we have desmos.com. We go to our graphing calculator. Our original function was 1 minus 4x, right? So there's our first line. Our new equation we said was x minus 1 and then divided by negative 4. So this is our inverse function. Again, remember you would always put y equals x to show what we're reflecting over. I'm going to change this to a dotted line so you can see. And then it shows the inverse relationships of each one. In other words, this distance here is equal and opposite to the other side. They're reflections of each other. So if we did this again for number 2, same idea. We start off with y equals x to the third minus 3. So we're going to take and switch the x's and the y's. So this becomes an x, this becomes a y, and we're going to solve for y. So we'll add 3 to the other side. And to get rid of a cube, we take a cube root. So that would be our inverse function. So we will go back to our calculator. We'll clear these two out. We'll leave our y equals x there. So we're going to do x to the third power minus 3. And then we're going to do the cube roots. We're going to open up our functions. And we're going to look for our cube roots. And that is going to be right... Maybe I missed it over here. I don't see it. Maybe that function's not there. So what we'll do, since we don't have that function or I can't find it, we'll type in x plus 3, and we're going to raise that to the 1/3 power. That's the same as taking a cube root. Right, and then you can see these two functions right here. I'll change this color. Are reflections about the y equals x line, therefore making them inverses of one another. So let's look at number 3. Right, we'll write down number 3. It says y equals 3 times the log of x squared. So what we're going to do is we're going to take the x and y and we're going to switch them. So x equals 3 times the log of y squared. So to do that, first thing what we'll do is we'll take this 2 out, bring it to the front. This will make our life easier. So 2 times 3 is 6 with a log of y. we're going to take this 6 and divide it to the other side. So x divided by 6 is equal to log y. And to get rid of a log, we're going to take this base of 10, we're going to scoop this up. So we get 10 to the x over 6 power equals y. That would be our inverse function. So let's take a look at the graphs and see what they bring up. Our original function is 3 times the log of x squared. So we have this piece here. Now the only part that we're going to focus on is going to be the right hand side. There is a way, let's see if I can make this work. I'm not sure that I remember how. No, I don't remember how. But anyway, this part here on the left would not actually exist. And then we would do 10, and we would raise that to the x over 6 power. And again, you can see this part right here is a reflection of this part right here. Ignore this red line on this side. This is an error on the graphing calculator's design, so we don't pay any attention to that at all. In number 4, again we have y equals 2 to the x minus 3. We're going to take this and switch the x and the y. So now we're going to log base 2 both sides. We do that so this cancels out. So now we have log base 2 of x equals y minus 3, and we'll add 3 to the other side. And this would be our inverse function for number 4. If we looked at the graph, again, we're going to probably have the same funny little issue going on. But our original function we said was 2 raised to the x minus 3. Oops, that's not what we want. There we go. And if we type in log base 2, that one I know we have the function for. And our result was an x with a plus 3 behind it. You can see again that we have that mirrored view, that reflection for that given piece. And then let's see, the last one in this set, it's a little bit interesting. Number 5, we're going to write y equals x plus 1 over x minus 1. We're going to switch the x and the y's. So y plus 1 over y minus 1. We need to get rid of this fraction, so we're going to distribute or multiply by y minus 1 on both sides. So that way the one on the right cancels. Now we end up with x y minus x equals y plus 1. We're going to bring all the y values together. So we're going to end up with xy on this side with a minus y. We'll end up with an x plus 1 on the right. So now we have a greatest common factor of x minus 1 equals x plus 1. And one of the interesting things about this one is we ended up with the exact same equation that we just had, which is interesting. So if we took a look at the graph and we typed in x plus 1 divided by x minus 1, whoops, we get this graph here. Let me change the color. So you get this image here, and it is inherently already a reflection if I was to fold it over the y equals x line. So in terms of this lesson, right, that's the ultimate goal and the plan for each one. If we skip to the last example, right, they ask us what is the domain and range of f of x, the function that we see right here. So we would say the domain is negative infinity to infinity, but it looks like the range does not go below y equals 1. So our range is going to be from 1 to infinity. What they want us to do is they want us to sketch the inverse function of this. So some of the things I would observe is that this goes through 0, 2. So that means I would expect this to go through 2, 0 on this side. And if we look carefully, right, we might see another number, maybe not. If not, what we're going to do is we're going to just draw a rough sketch. So we would expect this one to come out this way. Is it perfect? Probably not. What kind of function is this? This is a logarithm. And they want to know what is the domain and range of g of x. Right, let's write that without that extra parentheses. There we go. And so the domain and range is going to switch. So for the logarithm, the domain is going to be 1 to infinity. And this time the range is going to be negative infinity to infinity. They want us to find the formula. So right, so we start off with the y equals 2 to the x plus 1. They want us to find the inverse, right, to do the formula for g. So we switch the x and the y. And we're going to solve for y. So we're going to minus 1 to the other side. So x minus 1 equals 2 to the y. And if I want to get this 2 by itself, I'm going to log base 2 both sides. So therefore my result is going to be log base 2 of x minus 1 equals y. And that would be the function that I just graphed. So that wraps up lesson 19, and that should take you to the problem set. If you have any follow-up questions, let me know.